I will solve this Math Olympiad question, and we need to solve this equation for A. So which A solve this equation? And obviously we'll have three solutions or up to three solutions, and I'll try to figure them out today. There are different kind of ways we can use to solve this equation, but first I will try to see if there are any logic simple solutions for whole numbers. And I can simply try to test that until I either hit 36 or get over 36. And I can try with 1, I can try with 2, those two won't work. But if I try with 3, and I say 3 third plus and 3 second, this will be 27, this will be 9. So all in all, this will be 36. So already we have one solution, but remember, we have three solutions to this, but I will use the first solution here to get the last solutions. Now, we will use this in a bit. So what we want to do now is that we want to look at the first equation again and say a cubed plus a squared equals 36, but that's the same as if we write a cubed plus a squared minus 36 equals 0. And because we had this first solution, we know that 36 can be written as this. This ends up being smart, so we'll try and insert that solution, a cubed plus a squared minus 3 cubed plus 3 squared. And that still equals to 0. Now we will write this in another way. So a cubed minus 3 cubed plus a squared minus 3 squared still equals to 0. All right, before we continue any further, we need to look at... All right, before we continue any further, we need to get some formulas written in. So first of all, we know if we have a squared minus b, that's not squared, that's cubed, obviously. That's equal to a minus b times a squared plus ab plus b squared. And if we have a squared minus b squared, that's equal to a minus b times a plus b. All right. Right, and now we start by using this and adding up here. So we know that it will become a minus 3 times a squared plus 3a plus 3 squared. And this is the first part of the equation, so we can say plus a minus so this is the first part of this, and I'll just move the blackboard so we can see what will come next. So plus, and then we will use the last rule right here on this. So a minus 3 times a plus 3. All right, and I can just erase this. Now, this equation is equal to 0 because this is the same equation as we had over here, which basically is the same equation that we started out with. Now, we have an equation where, oh, there came something here. We have an equation where we have the same factor both on both parts. So we can read this a bit different. A minus 3 times a squared from here. So a squared plus and 3a, and we can take the a from here. So the 3a plus a, that's 4a. And then we can take 3 squared plus 3, so that's 9 plus 3, that's 12. So plus 12 equals to 0. 0. And if we look at this, now we see that we have two things timed together, which makes 0. So that means that either a minus 3 equals to 0, or a squared plus 4a plus 12 equals to 0. The first one, we have already solved that, that's 3. So the last two solutions come from this. Now this is a quadratic equation, and we can calculate the discriminant or delta. If we do that, we'll get minus 49. If we use this to calculate the solutions, obviously we'll get complex solutions, and we will get a equals minus 2 plus 2 root of 2i, or we will get a equals to minus 2 root 2i. And that's it.